Today, we are going to learn about geometric sequences. And how to sum them. Now, what is a geometric sequence? A geometric sequence has two components. Let's call them A, which is the initial value, and R, which is the multiplier. Now, sequence is such that, let's call it G sequence. First term is A, second term is the multiplier R times A, and then R square times A, and so on. So if we have n terms of the sequence, first term is A, second term T2 will be AR, T3 will be AR square, and so on. Now, seems a bit abstract, this concept. So question is there a way to see such a sequence? I'm going to show you that something that's very commonplace in the world nowadays, compound interest, is actually a geometric sequence. Okay, so let's go on to that. So let's say we do a practical example first of compound interest. Compound interest. Let's say you have $1,000 in a bank and it's compounded at 10% annually. So what does that mean? I'll drop the dollar signs from now on, just too cumbersome. So for the first year, year one, you have your initial investment plus 10% of $1,000. So that's 1,000 plus 100, that's 1,100. Now year two, it's this number that becomes the new amount on which you earn interest. So it will be 1,100 plus 10% of 1,100. That's 1,100 plus 110. And that gives you 1,210. Note that the interest earned on the second year is $210, whereas the interest earned here was 100. So you technically earn double here. Year three, we again do the same thing. It's now going to be interest earned on this net gain. And so this is 1,210 plus 191. And then this 1,331, and the net interest you earn for the third year is $331, which is again bigger than the interest you earn in your second year. And so this is how every year the interest you earn goes up. And this is something called a compound interest. In simple interest, this number would be this. So now I'm going to show you how this is a geometric sequence. So let's say our initial investment is A. And let's say the interest rate is R. And by this I mean that to get the interest, you multiply A by R. So basically in our previous example, R would have been 10%, which is 10 over 100, which is 1 over 10. So year one, you have your initial investment, and then you earn this much amount of interest. So your net amount is year two. Now this becomes your initial investment. and you earn interest on that thing. So if you calculate, if you basically reduce this, you'll see that this is of the form 1 plus r squared. So you're free, again, same trick. You take this as your initial investment and you multiply that to get your interest. And you'll see that this 1 plus r cubed, if you go on your n, you can see that this pretty much grows exponentially. Your net gain be 1 plus r to the power n. And so this constitutes a geometric sequence. Okay, now we want to move on to adding the terms of. Okay, so what do I mean by that? Let's say you have n terms of a sequence. So from AR square, and then the last term will be n minus 1 because you have n terms and the power goes as 1 less. So this is your sequence, and you want to calculate this sum. So the question is, how would you calculate? That's what we're going to do next. Let's start with writing down Sn again. Now what we're going to do is write down another sequence by multiplying Sn, and this is going to be AR square R1. I've shifted the two terms just to make some suggestive rearrangement to these two sequences, because the next step that I'm going to do is subtract Rsn minus Sn, and then you can see that all these terms till here, all of them, they will all drop out. So subtraction means all of them goes to 0, and all you're left with is a r to the power n minus a. And so if you simplify this, you'll get Sn r minus 1 a r to the power n minus 1, and this implies that Sn is a times 1 minus r power n by 1 minus r. That is the sum of a geometric sequence to n terms. That's the lesson for today.